All right, here we go. Question 14 from our Precalculus, homework number 11 in MyLab Math. It's a word problem. It says the cables of a suspension bridge are in the shape of a parabola, as shown in the figure, which you can't see here, but I'll show it in a second. The towers supporting the cable are 400 feet apart and 40 feet high. If the cables touch the road surface midway between the towers, what is the height of the cable at a point 100 feet from the center of the bridge? So if I scroll down, you're going to see they did provide a picture, but there's no way that that's going to be really big enough for you to see. So what I've done is I've copy and pasted that into my scratch work, and we're going to answer the question they ask, which is how high the cable is above the road surface at a point 100 feet from the center of the bridge. Now, the first thing you need to do when you're working on these application problems is you need to strategically locate the vertex. Anytime you can locate the vertex at the origin, that's going to be super easy for you. So here's what I'm going to do. I'm going to draw a vertical line straight down. That will represent my y-axis, and then the road surface will represent the x-axis. And what that does is that locates the vertex of our parabola at the origin. It also makes these other measurements easier to work with. Okay, so let's make a note of what we've got. We've got the vertex at the origin, and whether you know it or not, we know another point on the parabola. Right up here at the very, do you see up here at the very top of the tower? That would correspond to another point on the parabola. Now I know that that x-coordinate of the ordered pair would be the distance from the center to the tower. And it's 400 feet from tower to tower. Since we located the vertex in the middle, the distance from the center of the bridge to the tower there, that would be 200 feet. It's going to be half of 400. And the y-coordinate would be how high the tower is, because the tower stretches from the road surface up to the cable, which is the parabola. And so the y-coordinate here would be 40. And so again, if we make a note of that, that ordered pair corresponds to 240, and that's going to be just a generic x and y on the parabola. If you know the vertex and another point on the parabola, you can get your equation. So if I scroll up here and look at my parabola information, this is going to have a vertical axis of symmetry. Notice that the cables represent a parabola that opens up. And then I'm going to copy down the standard form of the equation of this parabola. So with my standard form written down, we know that the vertex of any parabola is h comma k. And so what that tells me is I can replace h and k with zeros. And also remember, this generic ordered pair, x and y, means that I can replace the x variable with 200 and the y variable with 40, and that will allow me to solve for p. So here we go. That's going to be 200 squared equals 4p times 40. And 40 times 4 is 160. I'm going to leave that 200 squared because that's going to get huge if I square that. Equals 160p. Dividing both sides by 160 is going to give me my value of p, which I'm going to leave it like that. And then I can go write my equation of my parabola in standard form. All right, so that's going to be x minus h squared Remember, h is 0, so x minus 0 is just x squared, equals 4 times p, which is going to be 4 times that fraction, times y minus k. But again, k is 0, so that's just going to be y. And then I believe 4 will go into 160 40 times. So we're going to have x squared equals 200 squared over 40 y. This is the equation of the parabola that represents the cables on the suspension bridge. Now, if you're wondering, is all of this needed? The answer is yes, because what they wanted to know is how high the cable is at a distance of 100 feet from the center. So if I let's use a highlighter to help show that. If I go 100 feet over, then I'm going to go straight up, and that's going to be a point on the parabola, which would correspond to the ordered pair 100, right? Because from the center over to that point would be 100 feet. And then the y coordinate would be how high. So do you see what this is telling me? This is telling me that I need to plug in a value of 100 for x and solve for y. All right, so coming back to the standard form of the equation of our parabola, we need to replace x with 100. That's going to give me 100 squared equals 200 squared over 40 times y. We will need to multiply both sides by the reciprocal in order to get y by itself. So the 40s and the 200 squareds cancel, leaving the y by itself. And then I simply need to do this multiplication. And this is a good opportunity to bring in the class whiz. So we're going to start with our fraction. 40 over 200 squared times 100 squared is 10. And what are the units? They're feet. And then what does that tell me? If I go back up to my picture, that's going to tell me that, see these lines coming down from the parabola? That's going to tell me how long I need to make that cable to drop down from the suspension cable down to the bridge to help support the bridge. That cable is going to need to be 10 feet long at 100 feet over from the vertex. And then coming back to our MyLab math to make sure that we are correct, the cable should be 10 feet long. And that's going to do it for that problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.